Right, next thing we're going to look at polynomials. Now, so far this year we looked at just the basic linear function. Then we looked at quadratics in a lot of detail. And that's pretty much as far as a 2-unit level will go. Extension, then we say, well, okay, now we want to consider all polynomials. We're not going to stop at power of 2. And the reason polynomials become so important is the other functions, the sine function, cosine function, log function, exponential functions, can all be approximated using polynomials as an infinite series. So in fact, all of these other functions can be considered as polynomials as well. But don't panic. We don't go into that much detail in this course as far as infinite series of polynomials. But some of you will do some maths at university, you'll experience some of those. So polynomials, very important. Okay, so some definitions. A polynomial is set up this way. So we have basically a string of algebraic terms and the powers of x. Well, let's define them. So now, this is trivial, of course. Pn, so the coefficient of x to the power of n can't be 0. Because if it was 0, it wouldn't be there. And if it wasn't there, then the highest power wouldn't be n. The highest power would be n minus 1. So, and n is always a whole number, or in fact, it's a positive, or 0, whole number, for it to be a polynomial. Okay. So yes, P0, P1, P2, all those numbers in front of the algebra are obviously called coefficients. The index, also known as exponent, are basically the powers. Now, the degree of a polynomial, sometimes called the order of a polynomial, is basically the highest power. So a quadratic would be of order 2, a cubic is of order 3, and so on. So a polynomial of degree n, whatever that highest power is. The leading term, which is interesting because if we write it this way, it's actually the last term. So that's why I guess sometimes, or most of the time, you see polynomials written with the highest power first, because the highest power is the leading term. So you often lead with the highest power. So it's called the leading term, as opposed to the leading coefficient, which doesn't have the algebra with it. So it's just whatever the coefficient is. So make sure you read the question carefully. If they're asking for the leading coefficient, then they don't want the x to the power of n part. They just want the number in front of it. And a monic polynomial is whenever that leading coefficient is equal to 1. Now, polynomial x equals 0, well, I suppose it doesn't have to be 0, it could be any number. But that's what we call a polynomial equation. So when it's equal to a number, it's an equation, something you can solve and find a value for x, hopefully. Whereas when it's equal to another pronumeral, most commonly y, then it becomes a polynomial function. So it's like a graph. Y equals polynomial x, we could plot it on the number plane and come up with a picture. Subtle difference, but there is a difference. Now you have roots of an equation. Right? So roots of the polynomial equation, whereas you have zeros of the polynomial function. Again, a very subtle difference. Okay? So the roots are the solution to the equation polynomial x equals 0, whereas a 0 is the value that makes the polynomial function equal to 0. Obviously, it's exactly the same answer. And sometimes you'll see people use the wrong word. They'll say zeros when they mean roots, and they'll say roots when they mean zeros. They are basically the same thing. And if we talk about the picture, we're basically talking about the x-intercepts. All right. Which one of the following are polynomial? So, is A... No. Why not?
Half.
What about it?
It has to be a whole number.
Very good. No. No. Can't have a fraction as a power. What about the second one? Ooh. Ooh. I heard a mixture there.
Have a negative power. It has to be greater than negative.
Right. No. Because if we were to rewrite that, that would be x squared plus 3 to the negative 1. And you can't have that negative power. What about the next one? Yes. Sure? Yes. I think so. Yes. It's okay. Because, of course, we could write that as a quarter x. Coefficients are allowed to be fractions, just the powers can't be. What about the last one? Yes. It's 7x to the power of 0. So it would actually be a polynomial of degree 0. Okay, what about number 2? Part 2 here. Is it monic?
It's not monic. No way.
And what's its degree?
4.
Yes. No, mate. Yeah, 8x to the power 4 cancels.
Yes, if you expand the whole thing out, 8x to the power 4 cancels with the 8x to the power 4. And so you do end up with a monic of degree 3.